Hello everybody, my name is Nate Olson. I am the manager of Enterprise Systems here on campus. Enterprise Systems provides a number of central IT services that the campus depends on, including Windows File Services, Blackboard, ImageNow, and so forth. Today I'm just going to give a short primer on server virtualization fundamentals. Very fundamentals. We're not going to get into much detail at all, but we'll see where it leads. So, server virtualization, some background. Server virtualization is the ability to run many software-defined guest machines on one physical host machine. The guest machines are often called virtual machines. You might hear VM. That term is just short for virtual machine. Types of server virtualization: there's full virtualization, where the host machine completely simulates the hardware required to run a completely unmodified guest operating system. And then there's para-virtualization, where the guest operating system must be specifically modified to understand the software-defined hardware made available by the physical host machine. That's kind of a mouthful. Para-virtualization is usually a little bit quicker than full virtualization, or has a little bit better performance. The reason being is that the host machine does not have to do as much work in para-virtualization versus full virtualization. A short diagram here. At the bottom, you've got your physical host computer. It really doesn't look like it. Let's pretend this is a server and not what appears to be a thin client. And that physical server has hardware. It's got a CPU. It's got memory. It's got a network card or cards. It's got some disk. And on that, you run a piece of software that's usually called a hypervisor. And there are many of these. You may have heard of Hyper-V, Zen, or ESX server. Nowadays it's actually ESXi server. ESX is being discontinued. ESXi is a little bit more lightweight. ESXi and ESX are VMware products. Hyper-V is from Microsoft, and Zen is both an open source product and was sold as a commercial product by a company called Citrix, although Citrix just recently open sourced the commercial version of Zen Server. And then on the hypervisor, you have individual pieces of virtual hardware. Each one of these small gray boxes represents a virtual machine. And each virtual machine has its own virtual hardware. And this hardware is basically provided by software. It's software masquerading as hardware. And the guest OS runs on top of that virtual hardware, and the application runs on top of that guest OS. And as you can see, at least on this one, on this physical server, we have 3 virtual machines. So we've already managed, at least in this case, the 3-to-1 consolidation ratio, so not so bad for just starting out. Now, why server virtualization is important? Electricity costs. Electricity for powering an entire room full of server class equipment is very expensive. That's why a lot of major players are locating their data centers where the electricity costs are the lowest. Usually nowadays near hydroelectric plants, geothermal installations, near coasts, that sort of thing. Electricity can be a huge part of the cost of running a data center. Related to that is heating and cooling costs. Usually the more electricity you're using, the more heat you have to dissipate. Heating and cooling is a huge cost, and with that comes its own set of challenges. You need to be able to remove the number of BTUs you need to remove from that room, and that can get quite expensive. Also, HVAC units love to fail and flood the underside of your data center floor or other nice equipment that you'd rather not have go for a swim. Network connectivity costs. Cabling an entire data center full of physical servers is expensive. Every time you need a new server, you have to have a switch port or ports for that server, and enterprise grade switch ports can get expensive very quickly. Usually when you go to server virtualization, you end up using less, at least nowadays, less 1 gig connections and more 10 gigabit connections. Whereas a little bit in the past, maybe 1-2 years ago, your physical server would have 8, there were a number of configs with 8 physical NIC ports for redundancy, different types of traffic, that sort of thing. Lately, a lot of that has gone towards a single or double 10 gigabit interfaces. So what used to run over 8 1 gig interfaces is now run over 2 10 gig interfaces, which allows for a lot more consolidation port-wise. You have a lot less switches to worry about. Now, I'm not saying that your 10 gig switches are a lot cheaper, but in terms of having to run cables and the labor required to do that and the space that all those switches take up, it can pay for itself. Space constraints. This is a big one. Until a couple of years ago, actually in the IACC data center, we were running out of space for a little while. And we had actually filled up both rows of racks that we have in that data center, and we had to knock down a wall and spend a lot of money to move or to enhance the heating and cooling in that new area, to get that new area powered, to buy racks for that new area. It was a multi-month operation, probably half a year to a year, and it cost a lot of money. Now, server virtualization, on the other hand, you can, in some situations, it depends on your consolidation ratio, how many virtual machines you can run on a physical machine, but you can manage to take 20 physical servers and virtualize those and put them all on one physical server. So if your 20 physical servers were 2 rack units apiece, they take up 40 U total. You could virtualize those possibly on a piece of equipment that only takes up 2 U. So you shrunk your footprint by over 20 times. That's a big deal. Also, think about it this way in terms of heating and cooling. You've also reduced your heating and cooling needs because you went from 20 servers to 1. In terms of network connectivity costs, you've reduced the amount of cabling that you need because instead of having to cable 20 servers, now you only have to cable 1. Same with electricity costs. Now that one server is going to use quite a bit of electricity, but not nearly anywhere near the 20. A reason that's near and dear to my heart is agility. In the past, when Enterprise Systems has had to take on a new customer, and we have had to buy server equipment to host that customer's services on, it's taken probably on the order of, I don't know, from start to finish to order the hardware, to get it racked, to get it paid for, to get it cabled, to get it powered, to configure it in the remote management applications, so on and so forth. From start to finish, a month, probably. That's probably on the good end, let's say 2. That's just not fast enough. Customers look at that and they say, that's ridiculous. I can go to Amazon AWS, I can go to Rackspace has their own cloud. I can have a virtual server in 10 minutes. I can pay for it with a credit card. And then you say, yes, you can. And then you lose their business, which I would like to accommodate campus's needs. So agility is a big thing. Just in this past month, I've had about 3 or 4 customers approach me and say, we'd like, one needed a licensed server, one needed a different kind of licensed server, another one needed just something to run a Microsoft SQL server. and then one is going to possibly need one to run childcare software. I could say then that yes, I can accommodate you as soon as I can spin up a virtual machine. As soon as I have a staff member free that can allocate that virtual machine, I can get going on accommodating your need. And the nice thing about that is, at the same time where I can respond quicker to campus needs, it's actually worked out so that it's cheaper. Our physical server costs for fiscal year 2014, if you would like to, and this is not with labor, it's just an estimate. Physical server costs are about $1,640 a year. A virtual server now will run you base cost, I believe, around $664 plus storage, where storage is about 51 cents a gig. So really, even with 100 gigs of storage, you're looking at $704. So less than half the cost that it used to be, and we can respond faster to campus needs. So that's a huge benefit of virtualization. Reliability. Computers die all the time. They die at the worst moments. And they die when you're already having a bad day. They die. When you've got 20 physical servers with spinning disks, power supplies, network cards, eventually something fails. It's just statistics. Now, when you consolidate more of those physical servers in fewer virtualization hosts, you gain a lot of reliability in that there aren't so many moving parts anymore. Now, in one sense, you have a statistical likelihood of things failing. In the other sense, well, now there's not so many virtual hosts, but with virtualization, it's very easy to move workloads from one host that may be having an issue to a host that isn't. Let's say one host has one of its redundant NICs go out, or one of its redundant power supplies go out. You say, well, I don't want to run on that for very long. You can, in order to safeguard those virtual workloads, move them to another host that's not having any hardware problems at all. And you can do that live, which is another large bonus of virtualization. And the next one is scalability and performance. A lot of times what happens with me or with enterprise systems is we buy a server 1 year, and it's perfectly fine for what that customer needs that year. Year 2, it's probably still okay. Year 3, we're starting to push it. And year 4, the customer's going, why is my application so slow? I can buy a better computer than this at Best Buy for $500. And they're probably right. What virtualization offers is the chance that as long as I've got spare resources in one of the virtualization hosts, I can increase the resources allocated to a VM if I have to. And it's not a matter of taking that hardware down and having to have an outage, and then, let's say, putting RAM in the machine or a faster CPU, although that's not really all that common. The RAM is somewhat common. Instead of having to have an outage for that, I can just allocate resources, in a lot of cases, on the fly. More CPUs, more RAM, more disk space, all without downtime. It also gives, from a scalability standpoint, if I need to suddenly spin up a number of, let's say my website gets really popular, and I've only got one web server, and it's a physical box, and that web server gets slammed, I'm out of luck until I can allocate more physical machines to serve those requests. But if I've got spare resources lying around in the virtualization host, I can just quickly spin up another one of those web servers and respond to the traffic that I'm getting, which is really important for things like football tickets, where the site got basically hammered at about 8 a.m. every time there was a home game. So that's another major benefit of server virtualization, is just the scalability and the performance. And the last is testing. Well, not the last. There are more benefits than this. This is the last one I have on my slides. testing and development. We have, at least in enterprise systems, a development server virtualization infrastructure and a production server virtualization infrastructure. And what the development side of the house lets us do is, if we have questions about, is this vendor software going to run in a virtualized environment? Is it going to run at all? How intelligent are the vendor's employees? What we had to do recently is we asked a vendor for the first time, we said, we have this new service that the customer wants in production. We're going to give you a VM on development first. And we want you to install your software on that. And then we could shadow that vendor and say, okay, this vendor looks like they know what they're doing. And that way they can work out all the kinks in their deployment procedure on our hardware in our development environment, which is much better than them doing that in our production environment. The hope is that when we allocate that same VM in production, they've learned from their mistakes and that they can now successfully deploy their program without having to do Frankenstein type things that they may have had to do in the past. Oh, it doesn't work, I have to be with this other customer in 5 minutes, let me do some things you'd rather I not do. So that's a big win. The other side of the house, at least for development, is if we need additional servers so that we can test in-house developed applications, that isn't difficult to accommodate either. The possibility also exists to, if we have our production workloads on the production side of the house, it's possible to move those to the development side of the house, at least clone them, maybe do a V2V virtualization to virtualization conversion, and run those on development then. And what that lets us do is we can take a sort of a snapshot of a production system and start doing some testing on it and see if what we're going to do is actually going to work or not, which is another large win, at least for server virtualization. And that actually is where my very short introduction to server virtualization ends. If anybody has any questions, I can certainly answer those, whatever they may be.
What kind of hardware do you use for virtualization? Server hardware?
The server hardware that we have right now is, I've currently got Dell R720s.
720s?
I think they are. And they both got they've all got dual 8-core processors. I forget what they're running at. It was one of the nicer Xeons. I believe my newer virtualization hosts have 384 gigs of RAM apiece. And they have two 10 gigabit, actually they have a converged network adapter because we are moving to a converged network where the storage and the data both go over Ethernet. Instead, right now we have data going over Ethernet, we have storage going over fiber channel. We're going to move to fiber channel over Ethernet, so a converged network, so that you need a converged network adapter for that. So they've got a converged network adapter, and they've got 8 Intel 1 gig NIC ports, and like I said, the 384 gigs of RAM and dual octa-core Xeons. So they're pretty beefy.
Is there an upper limit on VMs that you can run on each?
Yes and no. What it usually boils down to is you almost never, for the vast majority of cases that I have seen, or that I've even heard of, you're usually not constrained by CPU. CPU is not usually the major bottleneck that you're worrying about. Memory is a close second, but what it really usually boils down to is disk I/O. Usually at the end of the day, the number of VMs that you can run on a given virtualization host depends on whether you got enough CPU, whether you got enough memory, and whether you have enough disk I/O. And really, your disk I/O is probably going to be your lower, your lower bound. You can only run as many VMs on a host as you have disk I/O for that host, usually. But you can scale it awful high if you want to. But then again, it does get down to, there are other concerns beyond what do I want my consolidation ratio to be. It's what happens if I say I want to have a 50-to-1 consolidation ratio, and I've got the CPU and I've got the memory and I've got the disk and network I/O to do that. You may say, but I don't want the case where if one of my physical hosts dies, 50 VMs die with it. So there are considerations. You usually do want to go for a fairly high consolidation ratio because it pays off better. But there are also reliability concerns or availability concerns. Any other questions?
Not so much a question, just another scenario to address, which you're talking about the failure. When you have all those VMs, you can suddenly, one piece of hardware goes out, as Nate says, and you've lost 10 services. You can't keep copies of those VMs on other machines, and as you mentioned, quickly spin them back up on another piece of hardware.
And even beyond that, with the software that we happen to be running, vSphere, it's the vSphere family. We're running ESXi 5.1 right now, 5.1 update 1. And with that, there are a couple of features in vSphere. One's called high availability, where if you can put your physical host in a cluster, in a high availability cluster. And if one of those hosts goes down, the cluster has a way of telling, okay, that host died. And it will actually, because all those VMs usually live on shared storage, on some storage area network or some network attached storage or something similar, the host can tell that one host died. And they can give it a little bit of time before they're absolutely sure it died, but then they can, once they're sure, start those VMs up by themselves and redistribute them across the cluster. A level beyond that is called fault tolerance, where you can actually have a VM running on one host and have a twin running on another host at the same time. And what it does is any I/O that goes to the first host, anything basically that happens to the first VM happens to the second VM. Except the fact that if this first VM dies, the second VM instantly takes over with no downtime. That's fault tolerance.
Have you tried that here yet?
Not yet. The only reason being is I do not have the hosts in a HA cluster at the moment because I want to check on a few things before I do that. I do want to put them in a cluster though because there are very many benefits to that.
How many VMs are you running and how many hosts do you have?
Right now, we have 8 physical hosts that were purchased with central funding. Right now, there are only, I want to say 12 VMs. So you may say, well, 12 VMs and 8 hosts. Well, the plan is a lot of the physical servers that we have are going to be virtualized. So we can use them.
I hate to cut you short.
Okay.
But we gotta stay on time.
Sure.
Thanks, Nate.
Yep.